Hi, and welcome to this coding interview practice. We're going to focus on implementing the Logger class. I'm Norman McIntyre. Let's get started. So here we're going to begin by setting the scene. You're applying for a Java software developer position. You've signed onto the remote interview meeting. The lead developer says you'll be asked to code the following during the interview. So here's the coding request. You're asked to put together the Logger class, and it says create a command line Java application that by default, that is without any command line arguments, it displays the following usage information. So that is, if you just type Java Logger, it shows essentially the help information. So that's the first requirement. Second bullet there is the name of the log file to log to is called Logger.log. So they're giving you the log file. The third bullet, the message is a text message. So for example, hello world. And there's one message per line that is put into the log file. And the last bullet, you can delete the log file and you can view all the messages. So you can do both of those. So the idea, this is what the interview is going to be, and you'll have to code this. Now I'm going to take you through all the steps, step by step. I would recommend you follow along, and maybe even before you start, you can think about how you would go about solving this. Right? There's more than one way, but we'll show the way, at least a particular way to solve it. We're going to break the coding into at least 3 milestones, and actually I think, I don't know, I think we've got 7 or so milestones actually when we get to the end. We're going to show a demo of each feature at each milestone. We're also going to use get to track the source control changes for each milestone. So this get is a source control tool that pretty much everyone's using now, and so we'll use it as we make each milestone. We'll commit it to the get source control. Also, we're going to do all this from the command line. So the idea is we're going to use the javac for the compiler. We'll use Java to run the code, and we'll use get to commit the changes. So this is what the interview lead developer has shared with you, and then they ask you, are there any questions before you begin? And if you say no, they're going to leave you alone and come back in some period of time and see what you've done. So time for you to go for it. So the first action we're going to take is, do you have the command line tools needed? Now for this, we're going to assume the interview, they gave you a command line, just like the command line we've used in the class there on the that website that has our build environment, the Replit. So in Replit, you can open up a command line. Here, I'm typing javac-version to see what version of Java I've got. A javac-version or java-version to see the runtime, and then Java or get-version to see the version of it. That just confirms I've got the commands. Now, as a point of reference, you could do this on any machine that's has these commands on it, but we're going to say for the remote session they gave you this remote login. In this case, I'm actually doing it on a Mac for your point of reference from the Mac command line, but you can also do it from the Replit command line or any other command line that has these 3 Java or these 3 programs installed. Okay, so the action we're going to take, since we've got to do all this from the command line, we're going to make a directory. mkdir is make a directory. We're going to call it Logger, and then we're going to cd, we're going to change down into that directory. Okay, so we're down in the directory. We're then going to use the get-init command to initialize our directory. So the idea is we're going to put all our source code into this directory, and so we've initialized it. So it's now ready for us to start checking in code as needed. Well, time to write some code. We'll create our Logger.java class, or Logger.java file. Notice I'm going to have a public class logger. I put the constructor, and for the constructor, I just put a print line saying to do constructor. And then since this is an interview, I'm figuring I want to make it clear that I know there's not a destructor in Java because it uses garbage collection. The reason I point that out, often in an interview situation, they may ask you about the Java constructor and destructor and say compare that, say, to a C++ constructor and destructor. C++ does indeed have a destructor, but Java does not. It uses garbage collection. So type that in, just the bare minimum of code, and then compile it here as we see. Okay, next we're going to write the logger test file. So notice a good practice is anytime you're writing code to also write a test program to go with it. And so although the interview person did not ask you to do this, you're doing it to give yourself an advantage. You're saying you understand about testing, and you're putting a public class logger test. And the idea is that this logger test is going to test your logger class. In fact, notice right now all it does is creates a new instance of logger and just prints out the reference to that. So here we do a javac on LoggerTester.java. So this is your second source file in this project. Again, I want to stress you weren't asked to write a logger tester, but you're doing this to give yourself the advantage to show that you understand testing is important when you write code. Well, it's time for the first use of the get command. So since you've added two files, we will type get add Logger.java and LoggerTester.java. Those will be the two files you're going to add to this project. And then you're going to do get commit with a -m, the -m meaning you want to have the following message to go with this. And the message is going to be initial commit. So here you've got the initial commit. Okay, so we've got, let's see, at this point, we've got our commit, and then just to show if you do get log, it'll show, yep, you've got an initial commit. Notice that long number, AA766, that's a unique number given to your commit. So if you ever needed to refer to it, you've got a unique ID associated with it. Okay, at this point you've reached your first milestone. That is, you've got your initial Java code and you've got it in the initial get commit. So your next action, expand the implementation of Logger. So you're going to enhance your initial Logger class. Notice in this case you went ahead and added a method called display help. You added a method called delete, and you added a method called log. I recommend as you're watching this video that you are doing the same thing as you follow along. So go ahead and implement the logger class just as we show it here. This is going to be your initial implementation. Of course, you do the javac on Logger.java to compile that. Well, it makes sense you also need to update your logger tester class. So here in the logger tester, notice we add a system.out print line saying we will test help. So notice on logger we call the help method, and then on logger we call the log method, and logger we call the delete method. So we've called each one of those. The idea is we've updated our test code to match our code that we're testing on the logger. So we go ahead and compile that. At this point we can do our first run, so we do Java logger tester, and we do Java logger tester. Notice we see our print messages come there to the screen. So far so good. At this point it's a you've got a module of code you worked on, so it makes sense to commit those changes. You do the get status command. The get status command tells you what has changed since you've last edited the code. So in this case, we see we've modified Logger.java and LoggerTester.java. With that in mind, we do a get add, and we add the Logger.java and the LoggerTester.java. Once we've added that, we then do a get commit-m for the message going to say add method stubs to Logger. So again, we're showing the interview person that we know we should make a set of changes, get those changes working, and then commit them to the source tree. So that's what we've done. They're now part of the source tree. Then we can check our progress if we do get log. Notice we've got two check-ins. We've got two commits. The first one was, of course, the initial commit, and the second one is the add method stubs to Logger. This is very important because it's showing the interview person you know that keeping this trail of your changes is important. Notice there at the top or right of that, it says head is master. That means the head of your source tree is pointing to what's called the master branch. Okay, you've made two good steps, two good milestones. Your next action is to implement help. So here you enhance your logger class. You have the public class logger, and you add this method display help. Notice you go ahead and add from the printf. We use the printf for print formatted, and notice we have a string. We concatenate the string, and we put the usage information there, the \ns being the new line character. You go ahead and compile this using your javac, and then you can rerun your logger tester. You don't have to recompile it. You can just rerun it because you know it's calling this logger class, and we see that sure enough, where it says testing help, you see your usage messages of log and delete and view. Well, you've got another set of changes. So you do a get add logger.java, since that's the file you modified. You do a get commit with a -m saying you implemented help, and then you do a get log to show that, yep, you've now got three commits. You did the initial commit, you added the method stubs to Logger for the second commit, and then you implemented help. Okay, three good commits. The next action, implement the file methods. You've got a delete and you've got a log. Need both of those methods implemented. To do this, we begin on the logger class. Notice at the top we have to import java.nio.file.star and java.nio.characterset.star and java.io.star. Java.io was the original set of Java classes. Java.nio is the new IO, which was added later in later versions of Java. So we see we're adding now a private variable path, which is of type path. A path is used to represent the path to your file. And in fact, in our constructor, we now use the paths. Notice that was with an S, paths.get. If you give it the file, it will create a path for that. And so we get a this object called path now has basically the path to the file we're interested in, which is logger.log. We go ahead and compile that to make sure we don't have any errors. Part 2, we add our next method. This time we're going to add the delete method. We're going to go fill out the code in it. Notice we're going to put it inside a try catch because we're doing file I/O, and anytime you're doing file I/O, you could have an exception, and so this I/O exception could occur, and so we're catching that if it does. Also, we do a return files, and notice that's files with an S. Delete if exist. So the idea is if you call this, you're going to delete it if the file exists. If it doesn't exist, then you're not going to delete it. And that's going to be a Boolean. It's going to return true if it's deleted, or else false if it was not there to be deleted. Do a javac Logger.java to make sure you've got this code correct. Okay, you want to enhance your logger class for part 3. Here for the public Boolean log, notice we're going to also put this inside a try and catch. Why? Because we're doing file IO and we could have an exception. We'll go create the file if it does not exist. So we say going to this files class exist. So and we're taking the not of that. In other words, we're checking to see if that's if that returns false. Then we know that files.createFile can be called to create the file. Otherwise, it doesn't need to be created. Once we've got the file, notice we do a files.write, and we do a write using that path. We'll take our message that was passed into us, and we get the bytes on that message, and we convert it using this character, this standard character set. UTF-8 is Unicode text format of an 8-bit character set. That's basically the characters that you use on your keyboard. And notice also we're doing a standard open option.append because we want to append to the file, right? If this is a logger, we'll keep appending to it. So if all that works, that is, we don't have the exception, we return true. Otherwise, if we had some type of exception, we would return false. Of course, once we get this, we do a javac Logger.java to make sure we've got that correct. Okay, our next action we're going to take is rerun the logger tester. We don't have to change anything in the logger tester, we just run it, and now of course we're going to actually implement code for the log and also for the delete. Okay, we got us some more changes, so we'll commit those. We'll say get status to see what files changed, and only one file changed, the Logger.java. So we'll say get add Logger.java, and then we will do a commit on that. So get commit -m enhanced log and delete. So because that's what we did for this one. All right, the video is getting a little bit long, so the next action we need to take is implement the file method so we can view the file. But since this video is getting a little long, I believe I will stop it here and we'll pick up on the second video. Again, I encourage, before you go to the second video, make sure all your code is working like we've shown it in this video.